All right, boys and girls, welcome back to the drive-through for remix. This is getting frustrating, Solomon, but I don't think it likes it when I pause the video, so I'm got to do this in one take. So this is, let's see, this is page 554, number 9. I just spent the time doing this, but let me explain this to you, and then I'm just going to show you how to do it. I love that you asked this question because I've never taught you how to do this. You might wonder, well, why is it in the book? Well, there is this special theorem called Heron's formula in the book, but we are going to go into some law of sines later, and so you could use law of sines to do the same thing. So we haven't exactly learned how to do this yet, but it's a really cool formula. I think you'll appreciate it. Maybe you'll go look up how he figured this out. So you've already said this, but the lateral area for this problem isn't that difficult. This is a very weird looking shape. It's not like an open book exactly because it comes to a point, but I think there are two rectangles in the front that are 13 by 11. There are two rectangles in the back that are 15 by 11. So the lateral area contains 4 rectangles. So that's 2 that are 13 by 11 and 2 that are 15 by 11. So that gives you 286 plus 330. So the lateral area is 616 square units. Now to the tricky part. How do I find the area of the bases? They're these weird inverted kite Star Trek looking shapes. Well, what they are is it's 4 congruent triangles, okay? But you don't know how to find the area of a triangle up to this point unless you know how to find, unless you know the base and the height. Now, again, we're going to change that with law of sines, but in chapter 11, we skipped a section called Brahmagupta and Heron's formulas because well, you can ask me why I skipped them when I see you next, or we can FaceTime about it or whatever. But this is Heron's formula. The area of any triangle is S times S minus A times S minus B times S minus C, all square rooted. What? Exactly. It's not that complicated though. S is called the semi-perimeter. So you just add up the sides of the triangle and divide by 2. And then A, B, and C are just the sides of the triangle. So in this case, our A, B, and C are whatever, 4, 13, and 15, in whatever order you want. And our S looks like 15 plus 14 plus 13 divided by 2. That's 16. So the area of the triangle is the square root of S, which is 16, times 16 minus 4 is 12, times 16 minus 15 is 1, times 16 minus 13 is 3, and you get 24. 24 is the area of one of these triangles. Notice there are 1, 2, 3, 4 of those triangles, so we have to multiply that by 4. So our total area is 96 plus 616, and I believe that is 712 square units. I hope this works. Boom!